Hey guys, welcome back to another geometry video. Last week we began working on parallel lines and proofs having to do with them. So this lesson will continue, but before we continue, we'll just review a little bit what we went over last week. So parallel lines are coplanar lines that have no points in common, or have all points in common. And what that means is that parallel lines either never intersect, like this is a pair of parallel lines, or they overlap completely, so both lines have all the same points. Two distinct coplanar lines are either parallel or intersecting. So two lines, it doesn't matter what lines they are. If you have a pair of lines, they can either be parallel or intersecting. So they can be like this, or they can intersect at a point like this. So those are the only two possibilities for a pair of lines. They can be parallel or intersecting. We learned that a transversal is a line that intersects two other coplanar lines in two different points. So over here on the right, this figure has two lines, M and L, and this line over here is the transversal. And when two lines are cut by a transversal, it creates 8 angles that we can associate with these names over here. So the first type of angles are interior angles, and these are the angles 3, 4, 5, and 6. So interior angles are just these angles that are in between line M and line L. Exterior angles do not have, they don't share part of the ray, so they're on the outside of lines M and L. So that would be angles 1, 2, 7, and 8 on the outside or exterior of lines M and L. Alternate exterior angles are on opposite sides of the transversal and do not have a common vertex. So opposite sides of the transversal means that one angle is going to be on this side, the left side of the transversal, and one angle is going to be on the right side. So a pair of alternate exterior angles could be 1 and 8, because 1 is on the exterior of line M and on the left side of the transversal, and angle 8 is on the exterior of line L and on the right side of the transversal. So they're on opposite sides of the transversal, and they're both exterior angles. So another pair would be 2 and 7 for the same reason. Same side interior angles do not have a common vertex, and they're on the same side of the transversal. So they're either both on the left side of the transversal here or the right side. A pair of same side interior angles are 3 and 5 because they're on the inside of lines M and L and on the same side of the transversal. So 3 and 5 are a pair, and 4 and 6 are a pair of same side interior angles. Alternate interior angles are on opposite sides of the transversal. and do not have a common vertex. So opposite sides of the transversal means that one angle will be on this side and the other would be on this side. And interior angles are angles in between lines M and L. So a pair of alternate interior angles would be 3 and 6, or 4 and 5, because they're alternate, so on opposite sides of the transversal, and on the interior of both lines. Three and 6, and 4 and 5. Those are two pairs of alternate interior angles. Corresponding angles are one exterior and one interior angle that are on the same side of the transversal and do not have a common vertex. So, same side of the transversal, both angles will be either on the left or the right. One exterior and one interior that do not have a common vertex. So 2 and 4, 2 is exterior and 4 is interior, but they share a common vertex, so this is not a pair of corresponding angles. 2 and 6, however, is a pair of corresponding angles because they do not share a vertex and they are on the same side of the transversal. 6 is an interior angle and 2 is an exterior angle. So that is a pair of corresponding angles. Others include 1 and 5, 3 and 7, and 4 and 8. Vertical angles are basically angles that are on opposite sides of each other. So the vertical angle, when you look at 1, is 4 because they're on opposite sides of the vertex. And we know that vertical angles are always congruent to each other. So angle 1 and angle 4 are vertical angles and they are congruent, so they have the same angle measure. One and 4. Another pair is 2 and 3, 5 and 8, and 6 and 7. So those are angles that are created when we split two lines with the transversal. So here we have a proof, but before we do this proof, we have a theorem to learn. And this theorem states that if two coplanar lines are cut by a transversal, so that the alternate interior angles are congruent, then the lines are parallel. And using this theorem, we can solve this proof pretty easily. So in this proof, we're given that line EF intersects line AB and line CD, and that angle 1 is congruent to angle 5. And it wants us to prove that line AB is parallel to line CD. So the first thing we can do is state the given, which we already read. And using this information, we can state that angles 1 and 3 are congruent. And this will make sense if we draw a diagram of this transversal. So basically what's described in the given is that we have a line here and a line here, and these two lines are cut by a transversal. So this is line AB, this is line CD, and the transversal is line EF. And we know that angle 1 is here and angle 5 is here, because this diagram would be given to us, and angle 3 is here. And in this diagram you can see that angles 1 and 3 are vertical angles, and we learned that vertical angles are always congruent. So using this diagram we can state that angle 1 and angle 3 are congruent. Vertical angles. And through the transitive property, since we know that 1 is congruent to angle 5 and angle 1 is also congruent to angle 3, we can state that angle 3 is congruent to angle 5. And this is through the transitive property. From here, we're basically done with the proof, because now we know that angle 3 and angle 5 are congruent. And why is that significant? Because angles 3 and 5 are alternate interior angles. And in this theorem here, we learned that if alternate interior angles are congruent, then the lines are parallel. So we can, right now, just state that line AB is parallel to line CD. And this is because the alternate interior angles are congruent. So we can break down proving lines parallel into 4 different statements. And if one of these statements is true, then 2 coplanar lines are proven to be parallel. The first one is that a pair of alternate interior angles is congruent. And this is what we did right here. We found that angle 3 and angle 5 were alternate interior angles, and we proved them congruent. And therefore we were able to state that the lines AB and CD were parallel. The second statement is that a pair of corresponding angles are congruent. Remember, corresponding angles are angles that are on the same side of the transversal. They don't share a vertex, and it consists of one exterior and one interior angle. The third statement is that a pair of interior angles on the same side of the transversal is supplementary. So basically, if a pair of interior angles on the same side of the transversal, so in between the two lines and on either the left or the right side of the transversal, is supplementary, which means the angle measures add up to 180 degrees, then the lines are parallel. The final statement is that both lines are perpendicular to the same line. So if we have two lines that are perpendicular to the same line, so they make right angles with this line, then the two lines are parallel. And this is because there's only one way the lines could intersect to create a right angle. So if they are perpendicular to the same line, then they must be parallel to each other. So these four statements here, only one of them has to be proven in order to state that two lines are parallel. So when a proof is asking you to solve or to prove that two lines are parallel, try to find if any of these four statements is true. And once you get a conclusion that looks similar to any of these, then you can state that the lines are parallel. So here we have a problem, not a proof, and it asks if the measure of angle A is 100 plus 3x and the measure of angle B is 80 minus 3x, explain why side AD and side BC are parallel. So with this problem, they give you a diagram or a shape, and it looks like this. With the angle measures like this. So how do we go about solving this? Well, if we add these angles, angle A and angle B, what would we get? Let's try it out. The measure of angle A plus the measure of angle B equals, if we add 100 plus 3x to 80 minus 3x, we get 180 degrees, because the 3x minus 3x, they cancel out, and 100 plus 80 is 180. So we know that these measures add up to 180, and we should immediately associate this with supplementary angles. because these measures add up to 180 degrees. And you can further state that the angles A and B are on the same side of the transversal, because essentially this line here, AB, can be extended like this, and these sides AD and CB can be extended like this. So we know that these two are interior angles, and if we find out that interior angles are supplementary, like in this statement here, on the third statement, it says a pair of interior angles on the same side of the transversal is supplementary. If we know this, then we know that the lines are parallel. So we add these two angles together, and we got 180. So we know that these angles are supplementary. And they're interior angles because they're on the insides of the lines, AD and BC, while on the same side of the transversal, which is AB in this case. So through all this, we know that side AD is parallel to side BC, because we proved this third statement true. Here we have another proof having to do with the transversal and parallel lines. And before we get into this proof, there's a theorem I want to go over. So two coplanar lines cut by a transversal are parallel if and only if the alternate interior angles are congruent. So with this theorem, we can easily solve this proof. This proof asks us to prove that angle 1 and angle 5 are congruent to each other. And it's given that line AB and line CD are parallel to each other. And the transversal is EF. So the first thing we can do is state the given, which we already read. Next, we know that angle 3 and angle 5 are congruent because of the theorem we just stated. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. So angle 3 and angle 5 are congruent because alternate interior angles are congruent. And then we can state that angle 1 is congruent to angle 3 through vertical angles, because vertical angles are always congruent. And then through the transitive property, we can just say that angle 1 is congruent to angle 5. And that's our proof. And that was easy because we knew the theorem having to do with interior alternate interior angles. Transitive property. This is the last problem for today, and it gives us the information that the transversal EF intersects lines AB and CD at points G and H, respectively. If lines AB and CD are parallel, and the measure of angle BGH is 3x minus 20, and the measure of angle GHC is 2x plus 10, find the value of x, the measure of angle GHC, and the measure of angle GHD. So it gives us information and it wants us to solve three different things. First, it's the value of x, and then using the value of x, plug it into these expressions and getting the actual measures of the angles. So since alternate interior angles are congruent, and angles BGH and GHC are alternate interior angles, we know that these expressions here can be set equal to each other. So 3x minus 20 equals 2x plus 10. And if we solve for x, we can bring 2x to this side. And 20 to the other side. And we get that x equals 30. So we found the first thing, which is the value of x. So x equals 30. All we have to do now is plug 30 back into their respective equations. So the measure of angle BGH would be equal to 3 times 30 minus 20. Which is equal to 70. And the measure of angle GHC would be 2 times 30 plus 10, which is equal to 70 as well. And this makes sense because alternate interior angles are congruent to each other. And 70 and 70 are equal to each other. So the measures are the same and they're congruent. So we solved all three of these using the knowledge we have on transversals and angles created by transversals. That's it for today, and I'll see you guys next week.